Hello, and welcome to Slacker Publishing's set of training videos introducing the database Vertica. Vertica is a relatively new database designed primarily as an analytic platform. In this series of videos, we're going to introduce and do an in-depth review of Vertica's functionality. Vertica may be a little different from databases you may be used to, like Oracle or SQL Server, but it is becoming more prevalent in the database world, primarily because of its analytic capabilities. The goal of these videos is that by the time you get through this set of videos, you will not only understand Vertica's architecture, but also what makes it unique. A step-by-step presentation of the history, installation, operation, and differences from traditional databases will make you the company expert in no time. In the videos, the presentation will rely on custom slide diagrams, operating system commands, web page resources, and SQL editor examples. On the left side of the screen, there is a set of thumbnail displays. The displays are color-coded and correspond to each of the different types of displays I just mentioned. The web thumbnail will show a QR code to take you to the web page being discussed. The other thumbnails will show you the last display of that type. On the bottom of the screen is a progress bar showing the slides that make up the video color-coded by type. The cell of the progress bars will change to black when it is being displayed. This hopefully will help you to locate a specific portion of the session if you need to go back and review a specific topic. So what exactly is Vertica, and how does it differ from traditional database systems like Oracle, SQL Server, and DB2? The primary difference of Vertica is in the way it stores its data. While traditional relational database systems store their data in rows, Vertica stores its data in columns. But first, a little history about Vertica. Back in 2005, a number of university researchers, led by Michael Stonebreaker, started work on the concept of a column-oriented DBMS. The result of their work was the CStore database. Vertica Systems was founded in 2005 by Michael Stonebreaker and Andrew Palmer to create a commercialized version of CStore. Then, on March 22, 2011, Vertica Systems was purchased by Hewlett-Packard Enterprise. The software division of Hewlett-Packard Enterprise, which supported Vertica, was merged with Micro Focus in 2017. Finally, in January 2023, OpenText acquired Micro Focus and Vertica joined OpenText's suite of products. So as a commercial database, Vertica is pretty new compared to Oracle's over 45 years of existence. On the Stanford University website, the initial documentation describing the CStore product is still available for review. The CStore, a column-oriented DBMS, is an interesting paper that describes the initial project goals. Listed here are the people responsible for CStore, in addition to the project's goals, and an in-depth description of the database. I would highly recommend reviewing this document. I think it will help you to understand the unique concepts of Vertica. Additionally, we can go to the github.com website and pull up the actual source code and documentation for the CStore DBMS project. The last release of CStore was in October 2006 and is available as a free download. Vertica is privately owned and the internal specifications are unavailable. CStore's original source code can provide some interesting advanced knowledge for anyone who really wants to get their hands dirty. Again, I would recommend at least taking a quick look at the website and review the basic documentation there. So, enough with the history lesson. Let's take a look at what the goal in creating Vertica and what makes up the Vertica database platform. Vertica was designed to efficiently handle the processing of large amounts of data. It was implemented to use commodity service in a clustered environment. It utilizes a shared nothing architecture. The data is stored in a column-oriented fashion. High availability was part of the core design. And You can access Vertica using all your favorite standard ODBC, JDBC interfaces, and executing standard SQL commands. Don't worry if you're not familiar with some of these concepts, as we'll go through each one of them in detail. Vertica runs on a cluster of standard computer services, much like the machine you use at home or work. However, they're usually way more robust than that. The servers run the Linux operating system, and a number of various Linux implementations are supported. Each of the servers contained in a Vertica cluster is referred to as a Vertica node. Each node has a copy of the Vertica software installed and running. We usually refer to this as a Vertica instance. The Vertica cluster is a collection of these Vertica nodes. We can have a single node, or server, or a large number of these nodes, making up our cluster. The server should be similar in configuration, CPU, speed, cores, memory, and of course operating system. We need to look at how these nodes are organized in our cluster to fully understand how the Vertica database operates. This is really a key concept. Computer database clusters are usually implemented using either a shared architecture or a shared nothing architecture. So let's look at an example of each of these and look at their implementations. First, let's look at an example of a shared architecture. In this example, we're looking at a simplified Oracle clustered database implementation. Each of the nodes run an instance of Oracle, but there is a single storage array that all the Oracle nodes can access. Any of the Oracle nodes can access the physical database storage. Thus, in this implementation, the physical database disk drives are shared across all the Oracle nodes in the cluster. So this is what we call a shared architecture. Vertica, on the other hand, uses a shared nothing architecture. Each node has its own storage that only that node can access. Nodes can talk to each other over a network connection, but each cluster node has its own processing power, or CPU, memory, and storage. As our diagram indicates, Vertica supports multiple network connections to segment traffic. Typically, we would have a private dedicated network that Vertica nodes would use exclusively to exchange messages between nodes relating to database operations. Separate connections to the user network would handle communications to the database users and applications. Vertica was designed to be a column-oriented database. So what exactly is this, and how is it different from our traditional databases? First, let's look at a simplified example of data stored in row orientation. In this example, we have a table with columns for city, state, and how the cities rank population-wise. Contrasting that with a column-oriented scheme, each column is stored separately with a mechanism to link the rows together. In this simplified case, we show an ID that links the various row columns together. Looking at the two orientations, we can see that the data is all there in both methods. However, when we look how this is physically stored on the disk, we can start to understand some of the differences. In our row-oriented example, the data is stored in blocks on the disk. We start by placing our rows in a block, filling up the block as much as possible. That allows us to retrieve a large amount of data when we read that block into memory. In a column-oriented scheme, the data is stored in separate files on the disk. This means to retrieve a row, we would have to read 3 separate files. So why is this better? Well, first, remember our Vertica platform was developed for analytic processing. Here we are dealing with very large sets of data, and we're going to be looking at the various pieces of the data in different ways. With regards to the size of the data set, the ability to compress the data can have tremendous effect on the cost and the performance of our platform. When we look at the data stored in row orientation, hopefully you can see that all the columns are represented by different data characteristics. Compression can be very difficult and costly to implement. However, in a column orientation, compression can be implemented very easily. In our example, in our state column, we can eliminate the duplicate data columns and just add a link to the single value. Compression under Vertica is done on a column basis. And what's really cool is that every column can utilize a different compression scheme. In fact, Vertica supports quite a number of different compression and encoding schemes. That way we can use the best method based upon the characteristics of our data in that column. So here's a sample of all the types of compressions that are supported by Vertica. Another difference between row and column orientation has to do with the retrieving of data. Looking at a simple select statement against our city-state table, where all we want is the name of the state where the rank is equal to 7. In a row-oriented database, all the data from each row must be retrieved in order to evaluate our query. In our query, the city column is not required, but we must transfer it along with the state and rank columns because they're all combined in the same data block. In column orientation, since the column data is stored separately, only the columns necessary for the query need to be transferred. This leads us to a major difference between Vertica and traditional databases. This is another one of those key concepts. In Vertica, a table is a logical construct. It does not contain any data. It is just metadata that contains the definition of the table. In Vertica, a projection is the physical object that actually contains the data. So some details on these projections. A projection can only have columns that are defined in the associated table. A projection can have one or any number of the columns that are defined in the table. A table can have multiple projections. The projection data is always stored sorted. And every table always has a super projection associated with it, which contains all the columns of the table. For our city-state table, the table definition is stored as metadata as shown on the bottom of the diagram. We have a super projection that contains all 3 of our columns. We could also define a separate projection that only contained the city and rank columns. When Vertica executes a SQL query, it looks and determines the most efficient projection to use to satisfy the query. The super projection ensures that there's always a projection that can satisfy any query that you need to execute. Remember that Vertica promises high availability. Also, do not forget that Vertica is working in a shared nothing architecture. To accomplish this high availability and also provide the performance of parallel processing, Vertica locates the projection data using one of 2 methods. If a projection is small, Vertica will simply make a copy of that projection and place the entire copy on each node. Remember that each node is independent and the node cannot directly access the data located on a different node. If our projection is large, it will divide the data into multiple segments and spread those segments across all the nodes in the cluster. In our diagram, the projection has been divided into 3 segments, and one of those segments has been stored on each of the nodes. For these segmented projections, Vertica will create a copy of the segment and store it on a different node. These copies are referred to as buddy projections. How many buddy projections to maintain is referred to as the K-safety value. When you create the database, you can define this value. You need at least 3 nodes in your cluster to have buddy projections. With buddy projections, you could lose a node and the database would still continue to run. If you look at the formula here, to have a K-safety value of 2, we would actually need 5 nodes. But the diagram illustrates how 2 sets of buddy projections could be spread across our cluster. This is how Vertica can provide high availability in a cluster environment. Vertica can handle multiple node failures as long as the data is available in the cluster. Hopefully, these introductory Vertica concept has generated some interest to continue with your Vertica. Finally, as we wrap up this first session, I would like to point you to Vertica's website. Here you can find a lot of resources, including documentation and training. You will need to create an account with OpenText to be able to get access to the Vertica resources. In addition to Vertica documentation, one of the awesome things that Vertica offers is a free trial to download and set up a Vertica database. I encourage you to set up a Vertica account. Once you enter your information into the request form and submit the request, you will be requested to validate your email. After you validate your email, you will have access to a large amount of Vertica resources and downloads. At this point, you can request your free Vertica trial. In upcoming sessions, we will detail how to download the trial version of Vertica and set up your own Vertica database. That will give you your own vertical database for you to execute the examples we present and to explore and understand on your own. I hope you have enjoyed this initial Introduction to Vertica video. Future videos will cover a detailed step-by-step description on how to set up the free trial of Vertica. Then, as we present topics on Vertica, you will be able to perform the same exercise. This will allow you to quickly expand your vertical knowledge. Please join us for our next session. Thank you.